Okay, good morning students. Today our topic is area of similar triangles, that is after completing the basic proportionality theorem and similarity criteria. Now we have come to the part where we will be discussing about area of similar triangles. But before we discuss similar triangles, let's discuss area of similar figures. Area itself is a square part, so before going into that, let's see this example. Here we have pizzas. If you go to some shop, in some pizza shop there is a big pizza, and its diameter is 18 inch, and there are smaller pizzas also available, and its diameter is 12 inch. And the bigger pizza is 450 rupees and smaller pizzas are 225 each. So which one will you buy? You have exactly 450 rupees, whether you will buy this bigger one or these two smaller ones. And your target must be to get the maximum pizza. So which one is more? Here it is showing it is 18-inch pizza is more than 212 pizzas. Do you satisfy with this logic? Just think about it once and then pause the video, think about it, and let's go to the answer. Okay, thinking process is over. Now which one among these two you think is a biggest one? You get more pizza by paying either for one pizza or for two pizzas together. So generally we think that two small pizzas, each one is 12 piece, so our mind works in this way, plus that 12 plus 12 is 24 we are going to get here, whereas here it is only 18 we are getting. So naturally we tend to think that taking two small pizzas will be profitable, so because we will get more pizza is what we think, but it doesn't work like that, because we will be concerned about their area, कितना area में pizza है वो हमारे लिए important है, not about what is the length, that is this is 18 inch and this is 12 inch, that we are not least bothered about. Let's see how it works. These two things are triangles, we know that. This is also circle, and these two are also circle. And let's find this area, pi r square, pi into r. If diameter is 18, radius will be half, that is 9, so pi into 9 square. Whereas here it is 12, 6, radius is 6, so pi into 6 square plus pi into 6 square. So what happens? 2 pi into 6 square, that is 3672 pi. 72 into 2 again, okay, 6 square is 36 pi 36 pi 72 pi. So this is the area of these two together. ये दोनों मिलाएंगे तो हमको 72 pi area है, and एक बड़ा में कितना आ रहा है? 9 9 81 pi. Did you observe that? Because area में जो कुछ भी हमारे पास measurement है, it is multiplied twice. So when comparing similar figures, we should never think only in the terms of sides. It is about the squares of sides. So let's go to our triangles topic. So we have two similar triangles, that is ABC and DEF. So both are similar triangles. In this generally in this exercise we are least concerned about whether the triangles are similar or not, because in almost all the triangles it is clearly given that the triangles are similar. If not, we already know what are the criteria to prove two triangles are similar or not. So first what we will do is, whether they are similar or not, we will try. If they are similar, it is given similar, then your task is very simple. If they are not given similar, you have to prove them both are similar, then you have to come into the concept. Now concept here is, what is the theorem that we will be working on here is area of triangle ABC and area of triangle DEF. If you compare these areas, it is equal to the corresponding sides ratio का square, that is AB, and in this DE, that is AB square by DE square. This is the key concept here. Two similar triangles, if there are two similar triangles, the ratio of their area is equal to ratio of their area. We are thinking about area, not about anything else. Area, ratio of their area is equal to square of ratio of sides of corresponding sides. It can be AB DE or it can be BCEF, BC square by EF square. Similarly, you can write AC square by DF square also. So by squaring any corresponding sides ratio, we will get the ratio of areas of two triangles. So this is the main concept of this exercise. Let's go to the sums. So let's move on to the first sum. As I said, it is clearly starting itself they have given the triangle ABC is similar to triangle DEF. Let's draw them. So we have an ABC and we have a DEF. A, B, C, D, E, F. And area of ABC is 64. ABC is also given and EF 121 is given, and EF is equal to how much? 15.4, and they're asking for finding BC. As I said, what we have learned just now, area of triangle ABC by area of triangle DEF is equal to corresponding sides. तीनों में कुछ भी ले सकते हैं, लेकिन here we are concerned about this BC and EF. So BC square by EF square. So we have this. So we'll have to simply substitute and to get the answer. Let's substitute. Substitution part is very simple. Triangle area of triangle ABC is 64, triangle DEF 121, and BC we don't know, and EF we know, that is 15.4. Let's substitute. That is 64 area of triangle ABC by area of triangle DF 121 is equal to BC square, that is 15.4 square by BC value is, I'm sorry, just allow me to correct this once. BC we don't know. BC is what we have to find out. So it is BC square will be BC square only by what is EF? It is given as 15.4 whole square. Now by simplifying this, you will get the value BC square is equal to 64.1 into, if you want to do the simplification you can do, and you can find out BC square is equal to so here BC square is equal to, you send this 15.4 whole square to this side and simplify it, and you will get the BC. So this is how we do the exercise first question, and let's move on to the second question. Coming to the second question, see here, now unlike the first question, they did not mention which two triangles are similar. Instead, they gave the task to us. They are asking us to find out those two triangles which are similar. We have to prove the similarity first, and then we have to go to the proof of whatever it is. So let us see first what is given in the story. We have a trapezium ABCD, and AB is parallel to DC. So let's take this AB, and this is this CD, and these two are parallel, and other two lines are not parallel, and the diagonals of this trapezium intersect each other at point O. So the diagonals are intersecting at the point O. Now it is given that AB is equal to 2CD. Okay, we will use this information later. AB is equal to 2CD. So AB by CD is equal to 2 by 1. Okay, we will use this information later. Find the ratios of areas of triangle AOB by triangle COD. If you observe carefully, here we have AB and CD. So AB, CD. So triangle AOB by triangle COD is equal to AB square by CD square. हम लिख सकते हैं कब? If we show these two triangles are similar. Similar होने से अभी तक जो point हम एक ही point पे पूरा exercise चला रहे हैं, that is if two triangles are similar, then the ratios of their areas is equal to square of corresponding sides. So here we have the two triangles and corresponding sides का ratios भी है. All we need is we need to know whether these two are similar or not. And in the previous exercise we have proved this so many times. AOB and COD are similar. We have proved because O here this angle and this angle vertically opposite angles, and these two are parallel, and when this transversal is cutting, automatically these two will be alternate interior angles, so they will be equal. Similarly, by A criteria we have these two triangles similar. So proving these two triangles similar is a very easy task because we have done it already in the previous exercise. Let's do that once. So comparing these two triangles, which we need, triangle AOB and triangle COD. What is common here? Angle AO is equal to angle O. Instead of writing O, you can write angle AOB, angle COD also you can write. Both are vertically opposite angles. The logic is vertically opposite angles. Next you can write angle B is equal to angle C. So OBA, let's write OBA is equal to, since near B we have two angles, so let's write, it is better to write OBA is equal to ODC. Why? Because AB is parallel to DC and this is alternate interior angles. Instead of explaining all these things, simply you can write angle ODC because alternate interior angles. Let's write that. Now by criteria called AA, one angle is equal, another angle is also equal. By AA criteria, these two triangles are similar. Now we have come to the point, since two triangles are similar, we can directly, we know that the areas ratio is equal to corresponding sides square को equal है. Whether you write AB square by CD square or AB by CD whole square, you can write both are same. So is equal to AB by CD value is 2 by 1. So 2 by 1 whole square, that is 4 is to 4 by 1 or 4 is to 1. This is how we solve the second sum. Let's move on to third sum. Now the third sum in figure 6.44, again we have a trapezium. ABC and DBC, ABC and DBC are two triangles on the same base. Here itself they have given clue, on the same base. 9th standard we have done something, if you remember, that's a good thing, otherwise I will remind you once. And if AD intersects BC at O, AD intersects BC at O, show that triangle, this area of ABC by area of DBC is equal to AO by DO. Generally we must have a square, here we don't have square, so we have to observe this carefully and do. So now actually you will find this sum has nothing to do with any of the things that we have, any of the theorems that we have learned so far. So this is a sum of its own kind. So let's solve this. Here to prove this, always we have a custom called constructions. So let's see, since it is given same base, so here area formula involves base. Area of triangle ABC is equal to half into base into height. So we are going to use this formula, half into base into height. So what is the base here in ABC? BC is base and height we don't have. Let's construct a height. Let us make a height and let's call it AP, half into BC into AP. Similarly, we have another triangle, area of triangle DBC is equal to half into, again DBC is on BC only, BC base. So here base we will write as half into BC into, here also, here we have taken this height earlier, that is AP. Similarly from this side, let's take a height DM. Okay, DM. Now we need a ratio. So triangle ABC by triangle DBC is equal to half into BC into AP by half into BC into DM. So now naturally we try to cut these two, half cancel, BC cancel. What we get is AP by DM. Now this is what not there, this is not what they are asking, that is AO by DO they want, and we have is AP by DM. So now where is this AP and AO, that triangle we have to take? We have to take AO also there, AP also there, such triangle we have to take. So let us take triangle AOP, and the other triangle DO must be there and DM must be there. So DO and DM, so DOM, triangle DOM. Let's take these two triangles. If you observe, these two are similar very easily we can say, because here O and O vertically opposite angles, and this is 90 degrees, this is 90 degrees. So we can directly write angle O is equal to angle O, because vertically opposite angles. Okay, instead of writing O, you have to write AOP and BOM, because it is next angle APO is equal to angle, here it near MO, because both are 90 degrees. So by AA we can say this is one angle is equal, another angle is equal. By AA criteria, these two triangles are similar we have proved. Since these two triangles are similar, corresponding sides will be equal. AP by DM is equal to AO by DO. So here first we have proved this triangle ratio is equal to AP by DM here, and that is equal to AO by DO we have proved. So directly we can write area of triangle ABC by area of triangle DBC is equal to AO by DO. This is how we can prove. Next, fourth question we will complete. Coming to the fourth question, if areas of two similar triangles are equal, let's call triangle ABC and triangle DEF are equal. So then what happens? Triangle ABC by triangle DEF is equal to, means this DEF we are sending into 1 we are writing, and this one we are sending here. ABC by DF is equal to 1. Equal, prove that they are congruent. Prove that they are congruent. So by the theorem that we have learnt before this exercise, area of two similar triangles is equal to ratio of squares of their corresponding sides. That is AB square by DE square, BC square by EF square, or you can write the third one also, AC square by DF square also you can write. Everything is equal to 1. So AB square is equal to DE square, that is AB is equal to DE. Similarly, BC square by EF square is equal to 1. So BC square is equal to EF square, and BC is equal to EF. Similarly, the third side also you can take AC square by AC square is equal to DF square. So AC is equal to DF. So the three sides are equal. Three sides are equal. So by the criteria, last year if you remember the criteria, side, side, side. By SSS criteria, these two triangles will be congruent. Okay, that is how we will prove this. So these are the 4 questions in the part 1. The rest questions will be done in part 2.